Welcome back. In this session, we'll see the plot of this discrete time sinusoid, and we'll see indeed that pi is the maximum frequency, indeed the maximum frequency that we can have discrete time signal. So if we say x of n is suppose cos of omega n, if we plot this signal, so if we plot this, so for different values of omega, how will the plot look? And if what is the impact of this omega as we increase omega from 0 to pi? Let's see that. Let me show you that. So let me show the second thing. So, let me show you. I hope this is. So I hope this is visible to you. So this is the plot of cos omega n for different values of omega. As you can see, when omega is 0, this is simply a constant. So this is simply a constant from 0 to 25. Now, as I increase the frequency from 0 to pi by 6, you can see the sinusoid, I have some variation of this cos pi by 6, and it looks like this. As I further increase the frequency from pi by 6 to pi by 4 now, so this is a larger value than this, you can see now the sinusoid oscillates faster, means the values oscillate faster. You can check the values oscillate faster. You can take the value number of samples after which it repeats 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But after 13 samples, it repeats here. You can see the values here 1, 2, 3, 4, 5, 6, 7, 8, 9. It repeats after 9 samples. So now the frequency is more in this. So it does the oscillation faster as compared to the same way. If I increase the frequency further to pi by 3, you can see does now it repeats after 1, 2, 3, 4, 5, 6, 7. So it repeats only after 7 samples. You can see now it repeats after, I think, 3 or 4 samples. And here the sinusoid, that is the value of the sequence, repeat only after 2, 1, 2. So this repeats after 2. So this has the highest frequency. So omega equal to pi is indeed the highest frequency. Now, if I take omega greater than pi, if I take omega greater than this pi, what will happen to the sinusoid, or how will the values change? Now, let me show you that plot. That's visible. So let me show you that one. So let me show that one too. I hope this is visible. So this is the plot of cos omega n as we take omega greater than pi. So this is same as cos pi n. So this is when omega is equal to pi. You can see it repeats after 2. Now, as I take omega equal to 7 pi by 6, means which is pi plus pi by 6. So now omega is pi plus pi by 6. So this is greater than pi. So you can see now the frequency starts declining. The values start oscillating at less rate. You can check it, or you can compare the result. Now, as I further increase it to pi plus pi by 4, you can see the oscillation further decreases. And if you check it, the oscillation further, and if I say omega equal to simply 2 pi, this is same as cos of 0 and 0 and means constant. So this is cos of 0, that's always equal to 1. So you can see as I go beyond pi, the frequency, means the rate of oscillation will decrease as I go beyond pi. I hope this is clear from these two. Please plot it yourself in MATLAB or any other software that you can see. So indeed, omega equal to pi is the maximum frequency in a sinusoid. So this is true. I hope this will be clear. This is clear from this video. All right. So let me repeat the whole thing what we have seen in these three videos. We saw the relationship between continuous time sinusoid and discrete time sinusoid, means continuous time signal frequency was the relationship of capital omega with this small omega. We saw the relationship with omega is omega yes, or you can say omega. So, omega. So this is the relationship. Or you can write it in terms of f. So small f is related to capital F by this relationship. F to s. F by, so this is the relationship. Now this discrete time frequency, discrete time signal continuous time. So I hope this is clear. So this was the goal. Then we saw how to obtain a discrete time signal from a continuous time signal. Then we concluded that the duration of omega is 1.85. This is same as omega. So the maximum frequency is 5, and each sensor that you can have in discrete time signal person is can have the frequency from 0 to 2 pi. So the maximum frequency is 2 pi. Nevertheless, the frequency can vary from 0 to 2 pi. I hope it's clear from these few videos. All right, let me end it here.